Okay, welcome to the third class of the summer pre-course interactive mathematics with Mathematica. Okay, now on Monday, I had basically a fairly long chat with you guys about the philosophy of Basai education and why it is that I'm using mathematics as a basis for essentially developing your brain, okay, for problem solving, but at the same time laying the foundation for the analytics that will be part of your adult life, basically. Okay, it doesn't matter what area you go into, analytics is going to be a key feature. Okay, it's like in the old days, before you invent maybe writing. Writing was just something only academics would have to learn, I guess. But it became ubiquitous, so now everything is written. So you have to learn the language of writing. Likewise, analytics is going to be part of adult reality now. So mathematics is going to be the language that you really can't get away from. Okay, now. Today, what do we have to do? We have two things, okay? I promise you, well, I try to promise you that today will be the last boring day, meaning that this is the last day where we cover the mechanics. So the syntax, the mechanics, the things that you really need to know to operate in the language of Wolfram Mathematica. The other thing we need, I would like to do is also introduce what's called the ecosystem of the computation or computational intelligence. Okay, so maybe with to avoid the disruption in the flow, what I can start with that. I can start with the ecosystem. Now, if we backtrack a little bit, again, Mathematica was conceived and developed by a physicist, not by a mathematician and not by a computer scientist. Okay, his name was Stephen Wolfram. Essentially, he needed a computational platform that was able to process symbolic information. Okay, so in other words, from a computing point of view, y is equal to x squared is a programming call to multiply x squared and output and put it in y, right? Whereas a symbolic understanding means, yeah, you understand what x is. X is a free-ranging variable until you specify the range. And then y is also a free-ranging variable until you specify the range. But once you narrow y equal to x squared, it becomes symbolically tied together so that you know that no matter what value of x is, y can never be negative or whatever. Okay, so it's a symbolic understanding, and this allows basically anybody who can do algebra, calculus, matrix, graph theory, all kind of stuff on this platform. So that was basically the birth, like Mathematica 1.0, let's say. Okay, so I think what happened is over time, a lot of the convenient function, like plotting graph, finding the distribution, all this becomes so routine that they start wrapping this as a built-in function. So that's why it's not just a language, it's actually a library on its own. Okay, it's akin to Python being a bare-bones language, and then people build NumPy library, Pandas library, TensorFlow library, PyTorch library, scikit-learn library, and start piling on. Except with Python, it's an open ecosystem. Okay, so there's like a consortium. Think of it as a club that looks after scikit-learn library. Okay, and there's a club that looks after TensorFlow library, and they keep maintaining this. Okay, but it's still an open system. It's a little bit like Android. Mathematica, there's pro and con to this. The con is that the library is not so big, but the pro is that because it's sort of like one unit, monolithic body of library. It's a little bit like iPhone, okay? So it's iOS kind of thing. So the maintenance, it's very consistent across the implementation. And you can say that, you know, iOS has smaller library set than Android because Android is more open. But some people who like to use iPhone say, well, I like iOS because it's really consistent across all the applications in there. Okay, so open language like you know, say Python, Java, JavaScript, R. Think of that as more like an open system platform like Android. Whereas Mathematica is a little bit more rigid. It's a little bit more like iOS. Okay, so if you like working with it, great. And in fact, I like working with it. Only occasionally there will be times when the library is not big enough. Okay, there's some niche application. You can think of some niche application that is developed by an independent vendor or software developer. So that's sort of like in Android. So if you use iPhone, you can't use it, something like that. Okay, so there's some of that even in my work. Some of it is so niche, it's not even available in Python. It's only available in R, for example. Now, let me give you a bit of a rundown. The way I visualize this is that all Basai students, you know, if they use iPhone, it's consistent. Everybody can talk the same language. Likewise, with Wolfram Mathematica, it's consistent across you know, different projects. Now, thing is, though, I have to mention that yes, there are occasions where some platform has a huge legacy development. Okay, it used to be the same thing with C, but now it's not. So I'll give you one example. Okay. So in my conception, if you graduate with Basai, you should know Wolfram Mathematica. This is very good. If you are graduating from Basai and you specialize in applied digital intelligence, you should also learn open platform language like Python. Okay. So, you know, between Wolfram Mathematica and Python, and the fact that Wolfram Alpha is embedded within, you know, ChatGPT and large language model, you pretty much all covered. I have to mention a special case. Some of you are here because you're interested in, you know, biomedical technologies, okay? Genetic, genomics, that sort of thing. For that world, and maybe some other world, but at least for that world that I can anticipate, the most ubiquitous language they speak in is R. Okay, so there's a lot of legacy genomics, genetic engineering software that's written, packaged, that's written not in Python, not in Mathematica, but in R. Okay, so for those of you who are in that, you would say Wolfram Mathematica plus Python, because I think it's a very general purpose, very good, plus R. And if you know these three languages, brilliant. Okay, another exception would be those of you who are heavy into web development or, you know, specific application on mobile. Then you have to learn things like Swift or whatever, you know, or if you want to do blockchain programming, then there'll be a specific language like Solidity to write Ethereum blockchain contract or something. Okay, so the way I think of it is, you know, baseline is Wolfram Mathematica. If you're going to work with data science quite a lot, add Python. If you're going to work with biomechanical, biotech area, especially genetic genomics, add R. If you're going to work with blockchain, you might have to add something like Solidity or whatever. There's a few. I'm not an expert in that. If you're going to work with heavily into web programming or interface programming, then maybe you have to pick up another Swift or whatever it is. Okay, I think Swift is the one for Android. So very particular. Okay, now, so having said that, over the years, okay, the base of user for Wolfram Mathematica expand beyond physicists to just any academics. And eventually, it gets to the point where the library is so large, they have their own like internal archive of help, okay? And the way to access that, first of all, is that anytime, okay, let's go to a new one. Again, so my guess would be something like this. You want to do something, okay? You want to do something. You want to do a histogram, okay? Now, chances are what you think about doing is already been done by 1,000 other people. So try writing it. So histogram, okay? Right now, hi, oh, sorry. See, hi is in blue, but there's a list of this, okay? This auto-suggest means that all these are recognized functions. Okay, like autocomplete, except instead of autocomplete from Google, it's autocomplete from function library or function catalog. Okay, so it looks like, okay, I want to do histogram. So let's say, you know, I just autocomplete or I just type it. Okay, but how do I use it? How do I use it? Well, then you do this. I don't know if Apple is the same thing, but in Windows, you just type F1. Okay, and when you, oops, how come it's not? Okay. Okay, so actually, you know, if you have it on F1, it should bring you to this page. Now, this is going to be like, if you are familiar with, any of you have used scikit-learn in high school? Well, there's like a help page for scikit-learn, right? It's a bit like that, except this is more uniform because when you go to TensorFlow, it's a different style, it's a different documentation style. But this is, again, it's like iOS, so it's uniform. So all the function will say here. And you notice this is the template. It says when you call this function, again, what I'm trying to say is that in functional programming, you don't ask computer to do things. You call a function. When you call a function, different function will be set up differently to take argument. So these are different ways of entering argument. So you will notice, so there's some like, so if you notice the first line has one input and it's expecting what? Anybody? Curly bracket, what does it mean? It's expecting a list, right? That makes sense because you can't have one number histogram. Okay, a histogram only works with a whole bunch of numbers. So at the very least, if you're going to do a histogram of anything at all, you have to give it a list of numbers. Okay, now notice the second line. There is something else like a B spec. B stands for bin. That is a sort of like bin size, you know, because histogram, you can have the bin size, same thing with Excel. The difference is here, you have the option to not specify. So this would be one of those things where the same function can be called with one argument, list of number, or if you are more picky about the size of the bin, you can say, this is a list of number, comma, my preferred number of bins, 30 or something like that. Okay, so this is the first thing you see when you do F1. Right, and this works across the board. Again, you don't have to use one way for TensorFlow, one way for scikit-learn, one way for PyTorch. And then it's more detail and options. And this is where you dig deeper. Remember I tell you that you can use a function that says, build me a neural network. But if you don't specify further information, it's going to build you a sort of like a quick and dirty kind of thing, high level. But if you want to go deep, you go into this detail and options. And there are examples here. Good thing is you can click on it. And when you click on it, it's sort of like copy. And then you can paste it in your own thing. So I can copy this and then play it on my empty sheet and replicate. So this is how you learn. So this is a very good example. And there are more things like, for example, cool, nice example, you know, you want to get more jazzy or fancy with color or whatever. Okay. Application, how's it used? So use this for two things. I use this for two things. I myself use it for two things. One, you already know what histogram is. You already know what histogram does. You click on this page to say, what are the parameters I need to draw a histogram? Number two, histogram is a methodology you want to learn about. You don't know what a histogram is. You click on this page, and just by going through the example, you actually read through, you understand how this is done. And a lot of built-in function with data analytics, you can learn this way. Okay, so for example, let's say, okay, in my class, obviously, I'll be teaching classifier, I'll be teaching cluster analysis. But let's say you're on your own and you want to know about cluster analysis. Well, because there's a built-in function called cluster, right? Clustering or cluster, find cluster or whatever. You click on that page, it's going to take you through the example and will actually tell you what clustering does, even without going to class. So it's kind of like a shortcut for learning things. Now, of course, the mathematics behind it is better explained in a proper paper on clustering methodology, okay? But this is sort of like a visual, again, it's a very visual thing, interactive visual thing. Try to see what it does. How interactive? How can you make interactive? Well, when you copy this, right, you just try different things, right? Try different parameters, see what happens, okay? And this is how you learn. So this is how mathematics become like a second nature, okay? It's a bit like, I tell you that written language is important, but instead of just telling you to write on a notepad, I tell you to write on Microsoft Word. And there's like auto-suggest, there's spell check, there's word count. These are all the tools that help you write. It even writes, suggests that you're making grammatical error or maybe syntactic or style change. Sometimes it suggests that as well. It's the same thing. You're learning mathematics, you're learning analytics, you're learning the algorithm. You go through here, it helps you a lot more. Okay, it helps you a lot more. Right. So that's the first thing. That's one thing you can do. You want to try to do something. Now, there is, remember I said, if you click this, by default, it's that, right? Now, let's say you absolutely didn't know, okay? And you want to do histogram. Okay, and this is a shortcut that I don't really recommend. It was built in the later version of Mathematica. I don't find it particularly useful, but I'll mention it here because some of you may like it. It's free form. It's a little bit like asking ChatGPT to do things. Okay, so there's a little bit of a chatbot built in here, but very primitive and not particularly robust. So, for example, I want to say, you know, okay, let's say another thing is you want to do sine function, right? So it's obviously it's there. You know what a sine function is, but you know what a sine function is. You know what a plotting function is. But let's say I want to plot a sine function. Okay, and I don't know the syntax that does all this. Remember, functional programming, you have to do things by calling functions. So you have to call a function that says sine, and you have to call a function that says plot. But how do you stick them together, right? How does it work? What kind of argument? So one option is to go sine, and then press F1 and go to the help page, or you can go plot, go F1 and help page, or and this is a shortcut that I don't use that much, but just go to empty place and put in enter equal. Okay, it's going to give you this orange prompt. What it means is that this is free form input. Okay, so something you would write now, this would be English now. Instead of command, you just write it, plot a sine wave. Plot a sine wave, something like that. Okay, and again, shift enter. What it's going to do is it's going to try to interpret it into the language. Is this what you want? Plot, evaluate, sine of x, x from whatever. Okay, so this is a good suggestion. Okay, and it's sort of like a chatbot, you know, quick auto-correct, auto-fill kind of thing. But obviously, it's not necessarily going to be exactly what you want. So for example, you don't want to plot sine from -6 to +6. You want to -2 pi from +2 pi or whatever, okay? And if you can do this, okay, okay, evaluate sine and plot it. And then you can do, likewise, you don't have to do sine, you can do cosine, okay? So this is one way of doing it. It's called, I guess, free-form input, okay? Free-form input is it's a good way to get you going when you really, but I don't find it that useful. After a while, you get so used to F1 and function autofill. And even search, I just type in Google, Mathematica, how to do this. And sometimes somebody will write even better example. Okay, so that's something that came up in later version, free-form input. Now, free-form input is an interpretation of what you want to do in syntactically correct form. Okay, but there's no information. There's no information. Now, imagine this. Okay, now listen carefully. What if you want to do computation, but you also want to do it on real data? All right. Okay. Now, obviously, a bulk of it would be something like going to Kaggle website, data repository, download, scrape from the web, blah, blah, blah. Okay. But certainly, one of the quick way of getting to information is what? Just something like Wikipedia, right? Right? With say, I don't want to know anything about Thailand. I just search Wikipedia Thailand. Or I want to know about Thailand. Forget Wikipedia Thailand. Just Google Thailand. Okay. So that's going to give all the pages that has to do with Thailand. Okay. Now imagine all the things that sort of like basic information you might want to learn about Thailand, but only those that comes in, say, computable format. In other words, data about Thailand that you can play with. Okay, so obviously data about Thailand, like how do you spell, that's word. But if things like latitude, longitude, GDP, size of the country, how many hours ahead of GMT, okay, these are quantitative information about Thailand. So imagine you're trying to do Google or Wikipedia, but focus on data that you can play with. That's where computational intelligence comes in. It's in this case, intelligence means bits of information that's computable. So how do you access that? You do this. Equal, equal. Okay, try that. Okay. And then now here you don't write a sentence. It's not a free form thing, but you write a topic. Okay, write a topic. Now, so I can do this, Thailand. Shift enter. Okay, now this will take a while because it will actually go to internet. Okay, see? Now it draws this thing. Okay, so it interprets first. It confirms that, yeah, I'm talking about Thailand, right? Full name, country. Okay, this is a flag. This is, it's going to take a while because this internet, alternate name, internet code. So this is sort of like Wikipedia page for anything. Okay. Oops. Okay. So there's Thailand on the map. Okay. Oh, it's not equal. In MacBook, it may be different. I don't know. What you do is go to the plus sign, and there's what? Yeah. Sorry about that. Yeah, in MacBook, it may use something else. But in Windows, it's equal. But anyway, you can just use the plus. You guys see that? So it gives you all kind of information, maps. Now, all of this has two things, data and function. So even this picture, it's not just data, it's a function. That function is plot, right? Like a geographic plot. So all of this, there are ways you can play with this, and then you can download the data. You can do further computation. So this is a perfect way of starting any project. Okay, now think about it. You're going to have to do sort of like a capstone project on something. Okay, so let's say your project is about, I don't know, give me something you want to do. You want to have, I don't know, innovate something. Let's make something silly. You want to make hats, okay? So in this case, instead of this, you want to sell hats to Thai people or something like, I don't know. You just look up object hat, but instead of looking it in Google, you would look up in here. Now, hat is a generic thing, so you may not have that. But let's say you want to do something about Bangkok traffic or whatever, okay? So you can use this, and this will download all the data. Obviously, there are more data that has to do with Thailand, plenty more. But these are sort of like, again, high level, typical, okay? So Mathematica, the way it works with high level is a typical information set. Typically, what would you like to know about Thailand? GDP, neighbors, size, time, latitude, longitude. So these are all in here. Okay, population, obviously, right? And then once you got this, you can do certain things. You can plot it, you can do whatever. Okay, so that is what's called Wolfram Alpha. Okay, so it's not like Wolfram Mathematica. Wolfram Mathematica is like the language itself, the computational language, but Wolfram Alpha is like access to data in the world. Okay, so it's a little bit like Wikipedia plus or something like that. Okay, so obviously, it goes on forever. It goes on, yeah, GDP, Gini index, right? You want to know, it tells you that Thailand. So if somebody asks you quickly about Gini index, you can go to Wikipedia page, or you can go to here, just type equal Thailand, and look, Gini index is 0.35, world rank 62. So we kind of like halfway. We have the whole world of, I don't know, 200 countries. There's employment, okay? Unemployment, very low. We're pretty good, right? So we actually 200. We're probably one of the lowest, I guess. Long-term unemployment, yeah, that's pretty good as well. Total business tax rate, kind of stuff. So, again, healthcare, physician per capita, you have one doctor per 1,000, 0.9188, okay? And this is, of course, this is not nonsense, so it has a reference, so you can click down to this and get to information of like what information it's based on. Health index, maybe a little bit of this, page history, how many people have looked at page of Thailand. Okay, so I'm not going to go into this anymore, okay, except you should, and just find out how to use it. Once you got this, oh, road length, can I do something with it? GDP, unemployment, can I compare? Okay, say GDP of our country, how do I compare with other countries? Okay, so that's sort of like expanded ecosystem of the language. It goes into the informatics content of the internet of the world. Okay. Now, in the future, okay, again, once you learn the very mechanics of the boring stuff today, and we can start practicing, it's almost, you don't need to do that free form. It's almost a second nature to you. Okay. Having said that, in the future, to widen the ecosystem even further, Wolfram Alpha is now plugged inside large language model like ChatGPT. The catch is it's not free. The people who charge money is not Wolfram. The people who charge money, I think, is ChatGPT, because ChatGPT has what's called ChatGPT Plus, where if you pay a little bit more, you can access third-party plugin. And Wolfram Alpha is the #1 plugin right now. Okay, there are other very useful, fun plugin like a travel planner or recipe, a picture or something like that. A lot more fun stuff. But in terms of serious analytical stuff, the #1 plugin for ChatGPT right now is Wolfram Alpha. So if it's worth your money, I think it's worth your money. Pay about, I think, $20 a month or something. Okay, I haven't subscribed to ChatGPT Plus because I haven't had much time to play around with. I have plenty other things to do. But if you want to explore ChatGPT, don't just use it to write your English essay. Okay, use it as a portal to functionalities. Okay. So in the future, maybe your next class would start with ChatGPT on day one. I don't know. I don't know what the future kind of education will be. It might be slightly different. Anyway, so that's the deal. Okay. So if you go to, let's go to this empty page. That's a little bit too much. I'm just gonna, okay, well, I can leave it here. Okay, so right now, there one, okay, so this is standard language format. 2, this is free form. 3, this is Wolfram Mathematica, okay? This one is to put in a text. So if I did this, again, we did this already. Hello, nothing, okay? Now, if you want to use format text, for example, I can use it to write paper. I can say, okay, title, let's say title. And you can define your own format. It's a little bit like LaTeX, okay? So the building is this paper. Okay, so it's basically format, okay? And obviously you can define your own format like LaTeX. By the way, how many of you have learned LaTeX or use overleaf? Very useful. Okay, sidetrack, guys, but pay attention, sidetrack. You guys use Word, you guys use Word document, right? With Word document, what happened? You have to format things, right? This is a heading, this is that. And sometimes when you change things, you can't do it globally, okay? Imagine if you define that this piece of text is a title, this piece of text is a name, this piece of text is an abstract, this piece of text is the caption, this piece of text is an explanation, right? You can write it, just keep it. And then based on any kind of style specification, you can generate completely formatted. This is gorgeous. This is called LaTeX, okay? And academics do that. You know why they do that? Because academics have to sell to different market as well. And their market is academic publication. And each journal has its own format. Now, imagine that I write something and I want to try to send to this journal and maybe a different version to that journal, and I have to go edit everything so that the format match. That's going to be painful, right? But if I keep this as one file, title, abstract, introduction, body, experiment, picture, reference, right? And when I send to this journal, I just say, specify the style to that journal. And it automatically generates a PDF that looks perfect, okay? For that journal, use a different code, generate that, okay? So this is called LaTeX. Look it up, LaTeX. It's a why is it LaTeX? Actually, it starts from text, okay? So LaTeX is extension, but now everybody uses that. Or you can go to, yeah, see, it's so ubiquitous that it has its own font. Yeah, Overleaf is kind of like a free online LaTeX application. Okay, it's good, but it's not that flexible because you have to load everything to that. Okay, I use something like I use some other text. Okay. Anyway, so that's beside the point. Okay, now let's go back to us. So we got 1, 2, 3, 4, and 5. What's this guy? Now this is very good because a lot of the language is functional programming. In particular, Python is functional programming, and Python Jupyter copies the kernel way of writing commands. So it's natural. If you want to execute Python command, you can do it in here as well. In fact, you can link it to any external language that has this kind of functional interface. But by default, Python is the most popular. So when they do this, it gives you a Python command, okay? So you can actually do Python notebook in here. And it would look the same thing as Jupyter Notebook because, again, it has this kind of kernel thing, okay? That may be useful for certain things that needs external run. And you would use this, for example, if you have a particular algorithm that somebody somewhere in Norway wrote in Python, make it available for free in GitHub, you download it. It's not available in R, it's not available in Mathematica, so you just run it. Okay, so those are for the rare time that you don't have a built-in function. Now, I could link this to R, but I definitely don't even know how to write R. So, okay. So it's automatically, I think by default, linked to Python. It's the most popular open language in the world right now. Okay, so it's a bit like Android. So, good. Okay. So I've covered that. Now, so this is language extension. Now, what else? Let's go to the World Wide Web, right? There are obviously, you can Google something like, there's also Mathematica. Okay, let me do this first, demonstration. Okay. This is actually a website. Now, your connection. Okay. Okay. Next week, I promise you today is a boring day, right? Next week, we start to have interactive graphics and all that. But anyway, once you've done all this interactive graphic, people who have done this before, they like to share. So Wolfram Mathematica demonstration project is those things. So think of this as a shared community for mini application. That's why it's called demonstration. Okay, it's not an industrial software, but this has all sort of things by different kind of subject. If you look at this, there'll be hundreds in mathematics, hundreds in business, hundreds in this. Remember, I told you about visualizing the ISLM curve. I think one or two of you have studied economics a little bit. Okay, in here there'll be like ISLM curve demonstrator. Okay, so things that I really wish I had when I was an undergraduate, somebody, a few years, 10 years later, maybe. So all this, okay, all this is just obviously thumbnail, but when you click to it, you will actually go to the page that talks about this. So let's say this. So let's just click random page. Okay. Now, anybody knows what this is? Once again, this has double use. It's like a help page has two use. I know what histogram is. I want to know how to program it or the parameter set. Or I want to learn what histogram is. Likewise, let's say I know about color chromatography map. I'm a color scientist. I want to know how to program it. I can go to here. Or I don't know anything about color science. I want to learn about color science. I can come here and look at it. You guys know what this is, right? Well, this is actually what the RGB graphics people. This is how you map grids of red, green, and blue into all the spectrum of color that's available on a computer. Okay. Now, what does this page have? It has an app screenshot. It has more screenshot over here. Okay. If you download this thing, you get an app. Okay. But you can also, now, if you download an app, you can download an app player for free. You don't need license. But because you guys have license already, right? Chulalongkorn Batsai already paid for your license. Why don't just download the app to play it? Download the code, right? Download the code so you can copy and extend. Okay? People who make this available online, they want you to copy their code and do something more with it. Okay? They're not stingy. Okay? They're very nice people. So it's not, you're not copying what you should be nice and attribute, right? That this is, and people do that. Say, this is based on somebody else's work. So give them the honor. Again, be respectful. Okay, and also you can't do that. It's illegal. It's called plagiarism if you don't reference. So reference, let's say I want to use this, but I want to map it to a 3D object rather than just a flat template. Okay, so draw a little baby teddy bear and then drape it with color palette. I don't know. Okay, so I can start with this code, download the code, look at it, and because I do have the Mathematica software, you can extend it. So this is the larger community now. Okay, and it's huge. It's huge. Okay, you can share. I share one, but mine is not that pretty because mine was done for academic purpose. Okay. Now this means nothing to you guys. This means nothing to you guys, but it meant a lot to the Bank of Thailand. Okay. The Bank of Thailand had to have this, what's called this very precise formula for saying whether or not a particular commercial bank has enough capital. Okay? In other words, if the bank doesn't have enough capital, it may fall. And if it falls, you know, people who have a saving account, they lose money or whatever. Okay? So this is called Basel II. Basel is the name of a city in Switzerland. Two just means the second framework. The key word is that capital adequacy. And this is a formula. Now, this formula was decreed to us by a community of central bankers based in Basel. And because Thailand is an international banking, commercial, economics, our way of doing things has to be global, has to be, you know, sacred, international, right? So Bank of Thailand has to implement this. This is actually how the various parameters play out. So how do you explore different risks? So basically this surface tells you for a particular input parameters, the bank has to have this much money in the capital account. Okay, if they have below that, no good. Now in practice, I can tell you that in practice, the capital requirement is something like 7% on a risk-adjusted basis. Never mind what that is. But anyways, for some formula, you have to come up with a number that shows that capital has more than, say, 7%. But in practice, banks don't play that close, right? Then they don't walk on the ledge. So they'll maintain something like 11%, 12%. Okay, but the formula is there as a benchmark. Okay, so this was used, well, this was, I don't know when I wrote this. Must have been maybe when you were born or something, because that was 2000. Anybody can look at the date. I think it's 2011. Yeah, 2011. Okay, so that was when this kind of regulatory formula was being implemented throughout the world. Okay, so this is more like banking, but you should find a lot more interesting problem elsewhere in biomedical, right? In sustainability. So for example, you can look at environmental science application. So all kind of stuff in here, all kind of stuff. And you can also do, let me give you a sidetrack. You can actually do like a 3D model of your product and you can display here as well, okay? So for example, this is my sidetrack completely. Hold on, let me see. I can't see the, okay, I can see now. There, I think. Oops. Let's go to Wolfram. Okay, and I think logo there. Okay, so I'm just gonna show you the output. Okay, so basically, imagine you're making a product, except what I was doing was just drawing a picture of Basai. And right, so this is sort of like a 3D render of what Basai logo could look like. This was long before we This is so fun. Okay, hold on. And you can animate this. The point is that you can build this as an app so people can actually do design. So imagine that you are prototyping a product to a potential investor or to your client, but you don't know what the preference for your client is. Your client may like the color purple and you like the color green. So what you do is, instead of just having a fixed design with the color green, you have it as a parameter, right? And then show this as a I'm trying to see what's a GIF file. How do you play GIF on your computer? It should work. Try it. Anyway, it's animated, so you can animate. Yeah. So this is an animation from different shape or different colors. So you can go from green to red, red to green, or whatever. The point is that once you make it into an app, it's not interactive to you, it's interactive to your client. Okay, so this is very important for math students. Math students have to make sure your potential client or your potential investor can visualize your product. Normally, that's done two ways: physical modeling or computer visualization, 2D or 3D. However, with visualization in computer, you have to prepare the look, the form and the form factor, basically, right? Imagine that when you present that, always people are gonna say, "Can you make this thing a little bit bigger? How about in green? How about this? For that?" Forget about just making one picture. You give them an interactive picture, right? So let's say your product is a mouse, right? A computer mouse, right? And then you draw this thing in 3D and you try to sell to investor or sell it to your client. And your client said, okay, I really like this, but I want this part to be rounder, or I like this, but I want it in green. Instead of just, okay, let me go back to my office, redraw it and see if this is what you like. You actually give them an interactive mathematical knobs. Okay, so there's a parameter that say from round shape to square shape and interpolate. And your client can say, okay, all the way to the left, perfectly round. All the way to the right, perfectly rectangular. Let's have it sort of like a little bit squarish, but not, that sort of thing. So that's what you can do. So anyway, people have done this for a whole host of things. There are 1,000 different projects in here. Once you're comfortable with the language, you can get ideas from here. Okay? And think of this as your prototype. So imagine some guy, okay, this is not it, but let's say you're designing a cup, and that would be like a cup you want to sell. Okay. And your investor said, oh, I like this cup, but can I have it in green? Fine. Click the button. Oh, I like this cup, but I like it a little bit deeper so it contains more water or whatever. Okay, fine. Dial it a little bit. Okay. So this is the power of all this application. This goes under demonstration project. Just search Mathematica demonstration. It will bring you to this page. Okay. There are hundreds of this. Okay. In fact, for my emerging technology class, which I'm not sure I'm going to teach in spring or not, but if I did, a lot of time I would just have the student go through this demonstration project and pick out something that they think is sort of like a killer tech that they want to work on. Okay. So that's that. So that's demonstration. So beyond this, there's also community, and that's the same with any kind of software. There's always a community page. I'm not going to go into that. Okay, so let me take an early break today because it's a good place to end. Because when we come back, we're going to go to the mechanics again. Okay, so let's take 5 minutes. Try not to, try to be punctual. Come back on 11 o'clock sharp, and we can start. Okay, is it recording now? Okay. Okay. Very good. Now come back. So this is a little fun and games and where's that? Oops. Okay, so in my textbook, I use as an example Wolfram, information on global warming or so this is sort of like very good. Okay, so let's get back to our thing. Now, I suggest this, by the way. It's a very good practice. Okay. First of all, when I was a student, I think I told you the value of taking notes. I use physical notebook, right? I write down. Sometimes I don't even have to go back and read it. Just the physical act of writing commits things to my memory. That's how the brain works. You have this kind of like a state dependency. But anyway, most of you probably don't want to carry a paper notebook now. So just go to a notepad, something like this, class note. For example, okay? For example, this thing, you can say something like, before the break or something, part one, something like, oh, what did we learn about? Mathematica ecosystem, right? And what have we got? Oh, so we got to the language itself. Language itself plus equal to built-in function and lots of them. Okay, and then what else? Plus equal to wiki info IE Wolfram Alpha or whatever, something you do your thing, you do you okay, and something like check out plus minus demonstration community, all right, and then you go to the website http blah blah blah, and I do this now. I don't do this for taking class because I'm not taking class, but I do this when I run my consultancy project, when I work with a team. The reason I started doing this was because some of the consultancy project that pays money were done during COVID time, and I had to work with my staff via Zoom. And in order to say, okay, this is what we're doing, this is where we are, this is what we got to, we have like a common document. Now you can use some kind of work platform application, but I just use Notepad, right? So something like today we did this. In my project would be something like this guy did this code .nb, which then generate this kind of output. And then next task is to check versus validation set, whatever. Okay. So and I use this. I don't even use the word because I think when you write things in this case without any format, it forces you to be precise and catch your eyes with nothing to help. Right? You can't make anything bold. You can't make anything high, big, small. So it has to make sense. It's okay. I get it. Okay, we're here. Last time we did this, blah blah blah. This is how I manage my own consulting project. Okay. So I suggest you might want to do that, to start a notebook and do that. Anyway, so the second half would be something like what? Go back to more language syntax. Okay, mechanical, boring stuff that, okay, the sooner you memorize, the better. Okay, so let's go back to that. Let's make it bigger, bigger. Can I make it bigger, please? Dumbphone can make it bigger. Okay, it's bigger. That's okay, it's okay, got it. Okay, So this is a concept of computation. I'm writing this as a textbook, like I said, so it's not that simple. So what we did before, right? Okay, remember in the class note you should have written last time. What would you have written for this? You should have written something like, think of 1 plus 1 as a call to function plus 1, 1. Right? Something like that. Okay, that would be the class note item from, okay, as a shorthand. So this is a shorthand for call. Something like that. Okay. Again, I tend to give you little tips that I found over the years. They're not really hacks, but they're really good tips for optimizing your work plan. Okay, so we did this already. This thing about silence. Okay, we talked about that. Okay, assignment. Okay, this is a list, which is basically, think of this as a shorthand for a function called list. That's to create a list of things. Okay. Once it's a list, there's an order to it. So you can access the second element. You can access the first element from the back or second element from the front. You can access all elements up to the second element. You can access second element all the way to the back. You can access 7 to 8 as long as it's not longer. Okay. Now this means you are accessing this particular element -3 and 3. Okay. So let's do that. So this is list. Right. So that's my list. And if I did this, what happened? All the way to the second element. What if I did this? Get the third element from behind and the third element from the front. Okay. Now, what if I did this? Okay. I'm going to get an error, right? Because it doesn't exist. So one thing nice about functional programming is that unlike, compiler kind of thing, you don't wait until you compile it in another, 10 seconds or 10 minutes or 5 minutes or 2 minutes to find out that you did something wrong. You know right away you did something wrong. Okay. So obviously, oh, I see. Okay. Okay. Right. So we talk about this. Okay. Function. Okay. Function that cannot take any argument. Function that takes 0 argument, but possibly 1 occasionally. Function that takes this. Function can take a little. By the way, if I were to have a quiz, I don't think I should have a quiz. There's no time for it. I can ask something like, how many arguments does this function take? How many arguments does this function take? The right answer is not 3. The right answer is 1. It's expecting 1 thing. But that 1 thing happens to be a list, and that list contains 3 things, fine, right? But as a function, remember we talked about function, how many arguments does it take? 1. So this is the same kind of thing as histogram, right? A histogram takes a whole bunch of number, but if I ask you how many arguments or how many input does histogram take, 1 would do. But that 1 has to have more than just 1 element, obviously, otherwise it's going to complain. Okay, so this thing, okay, and so we did that we did last time. Okay, so this is my crazy way of doing plus, right? Now these are the fancy thing that you never saw before, which is D and integrate. So right here from here to here, this is the gap where I told you that Python cannot do. Something as simple as this, Python cannot do. Because it's not symbolic. It's numerical. Okay? Same, integrate. But I show you the nice way of writing this, right? Using the palette. Okay? Using the palette. So that's a nice thing. But this certainly would do. Okay? So this gives you, yeah. Integrate x to the power 2. But it's a nicer way would be, where's the palette? Palette. Math assistant, and use this kind of symbol integral sign. Okay, but let's I won't dwell on that. Okay, so let's go on. Oops, sorry, close this. Right. Now, okay, let's work a little bit more with lists because list is so useful. You have these are sort of like things that you might as well memorize because it's so useful. Range is a way of constructing a list, and the common sense say if you put in something like range 5 to 9, what do you think it does? Think common sense. Again, high level, common sense, typical response, typical content. What do you want? Range from 5 to 9 is 5, 6, 7, 8, 9. Okay? 5, 6, 7, 8, 9. Okay? Now, what if I did this? What do you think is going to happen? 5, 5, 9, and 2. It's not going to give you 5, 9, and 2. It's going to give you 5 to 9 instead of 2. Right? So, what if I just give one number? What do you think it's going to do? Start from 5 or finish at 5? Again, common sense, guy. Right? Well, it's probably going to finish at 5. Start from 1. So, this is a very common sense way of doing things. Okay? Now, what's cool is range work like this as well. Right? Now, this is what's powerful about symbolic as opposed to strong type language. I don't know if you know this, talk to your friend in computer science. Strongly typed function. If you expect an integer, you put in a real number, a float number, 1.2, it's going to complain. But here, because it's a mathematical concept, it's trying to say, can you do the same kind of thing for an integer? If you can do this thing for an integer, can you do the same kind of thing for numerical 1.2? And if it makes sense, it's going to do it. What do you think this function is going to do? It's going to range from 1.2 to 3.34.5 instead of 6.7. Now, obviously, instead of 6.7, it's not going to finish at 34.5. It's going to finish beyond that. So it's going to stop a little bit short. See? 1.2 plus 6.7 equal to 7.9. And the last number is 28. Why? Because if you add 6.7 to it, it becomes 34.7, which is bigger than 34.5. So it stops. So again, this is common sense, right? This is common sense. And this is now the king of all constructor is called table. Why? Because in life, table is everywhere. Okay. A student came to me last class, talked about this graph thing about social network, and I told him, in life, there are basically two things now that are going to matter to you, two kind of data structure, table and graph. Okay, so graph will come later, talk table first. So in this case, table constructor expect two things, some kind of expression with an index and the range of index. So whereas this thing, right, you said, get something from 5 to 9. Here, I'm explicitly making I index. So I get the same thing. Exact same thing. Okay? Again, why do I make life more difficult? Do it this way? Because we can generalize. Right? So now it's a table of I going. Now notice the second thing is a bracket. Okay? Because it's expecting two things. One, what is the index object? What are you creating? Number two, how does index range, the range of index? So the object and the range. In this case, the object is just I. That I goes from 5 to 9. This is boring, right? But you can certainly do a lot more. For example, you can do this, which you couldn't do before, with just a range. You can say, how about A? Okay, control minus I. Oops, I. Okay. Now, in this case, I. So that's when you have in algebra, if you have a blank between, that's like multiplication. You don't have to put multiplication. So what do you think is going to happen? It's going to get that, right? right? And you can do all kind of stuff. Well, how about once you got I don't like I make it I, oops, shift, oops, sorry. How about it? Let's make it big because it's, where's my mouse? Okay. There's a bit of a delay. Okay, so what if I did this? A underscore I, but then I shift enter, shift hat. Where's the hat? Hat. Oops. 3. Okay, what's going to happen? Shift enter, right? Because the first number is 5. 5 to the power 3 is 125. The second number is 6. 6 to the power 3 is 216, right? Table is the most powerful way of constructing pattern object. The pattern is described by this thing. So I want something that has a letter A. It has a subscript of index I to the power 3, and I want to multiply the whole thing by I. That's my pattern. That pattern will be replicated for each I specified next door. How do I specify? I specify I from 5 to 9. Okay? If I specify from, say, I don't know, some other number, 5 to 119 instead of 3, I'm going to get this. Yeah. This is all nonsense, right? I'm just making fun, kind of fun example. This is the fastest, most powerful way of creating pattern object, list of pattern objects. And instead of just doing just a pattern object, you can do a function. Okay. So let's see. Now this would not make sense because if I did this, A is going to be assigned to the last number. But certainly you can, oh, what is A? That's the last number. Okay. So you can do function in here as well. You don't have to just give a pattern. In Python, this is called list comprehension. Okay. In procedural programming, you would have to do something like for I equal to 5 ... 9 do A sub. Okay, see what I mean? Okay. So for procedural programming, it's a lot tedious, more tedious. So that's why we don't really work with that anymore. So again, this is okay. Table AI. Now the index doesn't have to be numerical. It could be this, right? Table AI. Okay. Now the difference is that I already used I before, so it copied that. So let's make it sorry, let's make it BI. Okay, so B sub I, B sub 12, B sub blue, B sub both, right? Again, unlike a strongly typed programming language, it's trying to say, can you make sense out of it? Okay, now let me do the opposite. Let me do the opposite. Okay, watch this. Okay, notice what happened. Because I multiply, I use I to the power 2. If I were a number 12, it does make sense. 12 to the power 2 is 114. But can you raise blue to the power 2? You can't. So it treats it as an index. All right? It's just an index. It's blue with a 2. Bold with a 2. Like a footnote or something. Okay? So this is the clever symbolic way. It's trying to say, what's your intention? Your intention is something raised to the power 2. But if that something were a number, fine, I'll give you that number. 12 to the power 2 is 144. But if you gave me both to the power 2, I'm not going to give you 2 boards or 4 boards. I'm going to give you both with the number 2 because that's all I can do. That's all I can do. That's all legit. Okay. So mathematics, by the way, the reason that some of you get turned off by mathematics is because you have to be precise. Okay? What is it? Is this a number? Is this a text? Is this a string? What mathematics does is try to flip this narrative around and say, okay, let's say you are not precise. You are not precise. You give me all kind of stuff, bold, blue, 12. I will try to be precise as I can make it. If it's a 12 to 2, I can make it 12 to the power 2. But if it's bold to the power 2, I'm not going to say, don't do this. Bad boy, bad girl. I will take it and I'll say, this is the best I can do. Okay? So in a way, it makes math a little bit more friendly, right? Because a real mathematician would be very aware, is this a text? Is this a word? Is this an ordinal number? Is this an interval number? Is this a ratio? Is this a signature? Is this an ID? Okay? Is it a one-to-one ID or one-to-many, many-to-one? They have to be conscious of all this. That's why mathematics tends to be, written in a very complicated looking syntax. Okay, what this does is to say, okay, you don't have to be precise. The algorithm will try to be precise as much as possible. So 12 to the power 2, yes, I can make it 144 for you. But blue to the power 2, I can't. Okay? If you want very deep blue, how do you do that? Well, actually, just to show you, common sense again. You can make dark. How about darker blue? See? There's an autofill. So obviously, darker blue exists. It's a dark blue. How do you know it's a darker blue? Okay, let's compare. Let's compare, okay? Let's make a list of blue and dark blue. Again, darker blue, how much darker? You can specify that. But if you didn't, common sense will tell you. And how do you know? This is blue. When you double click on it, you get an RGB object. Red equal to 0, right? Green equal to 0, blue equal to 1. So that's a blue object, all right? 0, 0, 1. So let's look at darker blue. Oh, okay. 0, 0.75. Okay? Again, you can, so now it's no longer darker blue, it's a funny color. Okay? Right. Now, let's be more useful. Raise your hand if you've done calculus. Raise your hand. It's okay. It's not a shame. I'm asking you to raise your hand high. Okay. Well, you obviously have seen Pascal triangle, right? Because that's part of derivation. Okay. Now, what is this? What is this? This is a table of factorial, right? So it's going to give you factorial. Now, by the way, I didn't say from the beginning, so obviously it's going to start with 1, right? So what's this going to be? It's going to be 1, 2, 6, 10, right? Oh, 24. 10 factorial. Okay, right? 1 factorial, 2 factorial, 3 factorial, 4 factorial, 120 factorial. Okay? Now, okay, what is this function? Have you seen this? 6 factorial, choose M. Well, I already gave the question away. So this is, anybody? Have you seen this? Stare at it for a minute. Those half the class should get what's happening. 6 is the total number of coins you toss. Head or tail, head or tail, head or tail, right? So I tossed 6 coins. How many configuration will have all tail? How many combinations? 1. How many combinations will land on all heads? 1. How many configurations will have 1 head? 6. How many configurations will have 1 tail? 6. How many configurations will have 2 heads? 15. 15, right? How many configurations will have 3 of each? 20. Okay? This simple relationship, we'll show you later what it looks like, is the basis of much of the mathematics and probability and statistics. Why? Okay, let me go all the way at the far end. Do you know that your profit function follows like a normal curve? Right? So some days you sell a lot. Some day you sell a little. Let's say you're selling noodles. Okay? You're selling noodles. And you plot the histogram of how many noodles you sell. So it go from 0 to maybe 1,000, say. Okay? But chances are in the middle, there's a thick histogram. You sell about 300 noodles a day. Okay? That shape came from this shape. You know why? Think of it this way. A guy walk past your store. Look, should I buy? Should I get noodles or should I not? Toss a coin. Yes. Get a noodle. The other guy comes by. Should I get a noodle? Toss a coin. No, I don't. Now, people don't do that. But think of individual persons. Typically, homogeneous client. Everybody has certain probability of seeing your noodle shop and ordering noodles. Imagine you have 1,000 people walk by. Each person has a probability 0.32 of stopping to eat at your noodles. What do you expect? How many noodles do you expect to sell? About 320. If you open your noodle shop for a year and plot the histogram, chances are you see the peak around the number 320. That came from here. That came from here. That came from here. No wonder normal distribution, well, I gave the name away. This kind of bell curve is everywhere because it's so easy to generate. Reality is like a simulation done by nature. Okay, simulation done by computer, that's simulation. But in a nature, that simulation by having people walk by and look at the noodle shop, that's reality. So nature's simulation is reality. Okay? I bet you never heard that before. Now, what's cool about table is you can obviously nest it. Yeah, I'll just do this. And this will create the first. Now, if I did this, and I do something like a table form, a matrix form, format in front of it, I get this. This is Pascal's triangle, right? So I did this before, right? 1, 5, 10, 15, or whatever. But now I'm indexing this guy as well. So this is how okay? So let me see if I can do this. Let me see if I can copy this. Now, this is not going to look very nice, is it? I don't know. Well, can you guys just type this? Okay, just say, type this. You can type this, right? 6. Just type 6 factorial. Okay, shift backslash. Oops, shift back. Control backslash, sorry. I don't know about MacBook. What's MacBook for that? Command backslash. Okay, command backslash. In Windows, it will be shift backslash or control backslash, sorry. So 6, okay. So let's do something like 6, choose 3, 2 factorial, 6 minus 2 factorial. Okay, that's it. Do this first. Do this first. By the way, this is how I write. I write in real number, but then I keep substituting variable. So now, what if I want a table of this, and I want from 2 to 5? I just make a table. What did we do before? So I make this, comma. Now the pattern is going to be 6, choose I, right? So I'm going to make 2. When I'm satisfied that this is correct formula. So this is a correct formula applied to 6 and 2. So now I'm going to apply to 6 and I. Okay. So now I'm going to apply to 6 and I. Now, if I want to start from 0 to 6. Okay. Oops, sorry. Right? I get this. Okay. So yeah. Are you caught up? Now, I don't want this to just work for 6. I want to work for 7, 8, 9. So I can make this n. Go down and make this n. Whenever I see 6, I change it to n. And now, oops, I iterate over n. So I make a table. It's very hard to see the mouse. Table. Now I iterate from n. N 6 to 9, 8. See? Right? 6, 7, and 8. Now, I want to look nice. So I put this in a table form or something. I can use matrix form or... Yeah? Now I have to make it small because I can't see all the number. See? Right? So what's this? This is 6, choose 6. So 6, choose 0. 6, choose 1. 6, choose 2. This is 7, choose 0. 7, choose 1. 7, choose 2. This is 8, choose 0. 8, choose 1. So what's this number? 56. If you toss the coin 8 times, how many configuration will give you 0, 1, 2, 3 heads? Right? There are 56 configurations out of all of this. So that's probability of getting exactly 3 heads from 8 coin toss. Okay. Now this is just configuration count. The reason I can call it probability is because I make head and tail the same. Okay. Now, if head the same and tail do not have the same probability, then obviously it's not going to be just 56 divided by the sum, because head and tails have different probability. Okay. But let's say head and tail have equal probability. Probability of 3 heads in 8 coin toss is given by how many configuration gives you 3 heads given all the configuration. Okay. So that's simple. Now, array, I don't use very much, but you can, array is a little bit, it's not as general, because what it does is that it gives you index. Oops, sorry. Let me clear A first. So I made the assignment. So now it's go back to nothing. See, except what it does is it gives you a bracket. Yeah, and it's not. I use it occasionally. Now, what about this? If I give you two number, it's going to give you a 3 by 2. So array is kind of like this, right? So if I give 3 number, it's a tensor. 4 number is also a tensor, but 4 depth, right? So this would be something like a black and white screen. Why? Because it's got 3 rows, 2 pixels each, and each pixel has 1 value. So it's a black and white screen. Okay. Now, so if I want to say something like RGB, it's going to look like this, right? RGB. Okay. And how many rows? Let's say it's 9 pixel by 16 by 3. Okay, that's it. So these are all the information that you would store to draw this picture. You have the RGB number, 1 for R, 1 for G, 1 for B. You store it in the last thing. And each of the 9 rows, you have 16 pixels. Each pixel has 3 numbers. Okay, so this is a space. This is a placeholder. You have to specify actual value. For example, 101. What's that going to be? That's going to be all red, no green, all blue. So that's going to be what? Bright purple, right? What about 0.7, 0.7? That's going to be a dark purple. What about 0.5, 0.5, 0.5? That's going to be gray. What about 0.1, 0.1, 0.1? That's going to be really dark gray. Okay, so forth. Yeah, so this is a typical information set for a computer screen. Now, in reality, what happens if you have a video? You're actually going to need another index. This one is going to be indexed for time, right? Because it's a moving picture. Okay, so it would be something like I don't know how many minutes you have, how many screenshots you have. Yeah. Right. Okay. Now, this is the last difficult thing that we have to learn today. Okay. Last difficult thing to learn. For those of you who've done mathematics, Python already, what I'm going to do is just tell you how to make a dictionary. Okay. So basically, what's a dictionary? It's a lookup table, right? It's a lookup table. Let's make one. Let's make one from scratch. Okay. Let's say I want student. Okay. Student. Okay. Okay. And I give a student ID. Okay. Say my ID. Okay. And I want this to say Pujai. That's my name. Okay. So let's say I have 2 students. What I'm going to do is this. Okay. 1, 2, 3. Okay. Just type it. Okay. This is the key. Okay. It could be anything. All right. I can make it a number. I can make it quote. Let's make it a quote. Because sometimes student ID, just to emphasize that it's not a number. You should do operative mathematics on it. Okay. Minus sign, greater than sign. Okay. When you put minus sign and greater than sign, it contracts, become an arrow. So 1, 2, 3 points to my name, Pumjai. Okay. Okay. Let's do the other way around. Let's go Pumjai. Okay. Say this is I want to know what my student ID is. This is my ID. Okay. Well, can just use the number for now. It's okay. Okay. And another guy, his name is Pai Ju. Okay. His student ID is 456. Okay. That's it. Let's make this. Now, this is a list of pointing. Okay. 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 Will you agree now? This is my registrar. This is my registrar. Okay. Now, what's important here? First of all, let me teach you what's important. What's important is that Pai Jun can only point to one number. If Pai Jun points to more than two numbers, that's bad. But if it's possible to do this, can I do this? Can I do this? In a student ID, no. But imagine that this is my nickname. My name is Pumjai, but my nickname is ID, but I'm the same person. This is doable. Okay? Many to one is okay. One to many is confused. Why? Because the left side is called keys. The right-hand side is called values. If you have one key pointing to two values, it's indeterminate. For those of you who are really keen on mathematics, this is what definition of a function is. A function is a lookup table where if you give me a unique key, I give you a, sorry, one key can only point to one value, but many keys can point to same values. That's what makes it a function, right? So f of x has to equal to something, but f of y can also equal the same number. That's not a problem. But every time you give it the x, same x, you have to get the same value. Yeah. So this is what this is valid. This is valid. So let's let's make another person who's not an alias. Okay, a thumb fun. Your TA, and her staff ID is 456. Okay, would you agree that? Okay, so this is my registration. Okay, now this thing I'm going to make it a dictionary. So I'm going to call, just like a list construction function, there's a construction function called association. Association, this. By the way, new line doesn't matter in Mathematica. Okay, rarely, sometimes it does, usually it doesn't. Okay, okay. So, okay. Okay. Just to emphasize, sometimes I do this. Okay. Doesn't matter because new line doesn't matter, right? Now, what happened is I create what's called an association. This association, let's give it a name. Staff ID equal to this association. Okay, just type exactly what I did. Okay, enter. Okay. Now, first of all, you would notice that the output gives you something very interesting. It looks like a list, but it has a funny bracket around it. That funny bracket, like the curly bracket, is the last thing you have to memorize. Okay, you have to memorize a square bracket is for function. Round bracket is just to put things together so it doesn't get separated. Curly bracket is for a list, and this funny bracket, less than, straight line, greater than, this is a dictionary or association. So instead of doing this, I could have done this. And in fact, this is what I tend to do. Instead of doing this, I just say, okay, it's an association. Now, I don't know what the straight line in Apple is, but for those of you who are from Apple, it's flat. So now I have a dictionary. So now I can do this. I can say, look up staff ID for me, please. I don't know what staff ID for Atom Fund is. 456. That's it. It's a dictionary. Okay? It's an alias. It's a dictionary. This is the second most important, most powerful things you are going to use. The first one is table for constructing pattern and also for keeping storage. Second thing is association. Association allows you to refer to a bunch of things with just the key. Okay. Now, why is this useful? Because a lot of times the values can be like a gazillion thing, right? You just want to name it. So think of this as a convenient way of naming stuff. Okay, convenient naming stuff. Now, once I have this is like if you're going to take database class, the concept of keys and values is going to come in handy. For example, if I say, if I have this thing defined, okay, this thing is defined for me. I've never seen it before, but I know that it is a key. It's a key value tag. It's a lookup table. It's an association. I want to know what are the keys. Well, just put in a function called keys. Pumjai, Paichum, Atom. What are the values? Right? And it comes in that order. Again, it is a list, so it has well-defined order. So if I did something like, if I try to access using this double bracket and I go to number 2, okay, works as well. Now, nobody would do this because the whole purpose of having an association is so that you don't have to remember the order, okay? So I'm not going to say, what's a second staff's ID? That's not used. It's doable, but it's not used, okay? So I just want to show you that it is still a list. Fundamentally, it's a list, but it's a special kind of list. Special kind of list that allow you to, okay, what's Pumjai's list? Okay. Okay. Now, I'm going to teach you one more function, which is so useful. It's called a map. But instead of teaching you the function, I'm just going to tell you the shorthand. You guys remember this? You guys remember this? @ sign, right? It's a function, right? Right? So instead of doing staff ID, open bracket, close bracket, Pumjai, hey, let's do this. Oops. Where's my mouse? I have to figure a way to make your thing bigger. Exactly the same, right? Now, here's a fun thing. Here's a fun thing. Here's a fun thing. Okay. And this is the last thing for today. Yep. Good. Good timing. Perfect timing. What if I want staff ID, not for one guy, but for a list of persons? Let's say I want not just Pumjai, but how about Atam for this one? Now you can imagine that record is 1,000 long, right? Right? And I just want, say, 5 students. I can certainly do that. So instead of 1,000, we have 3, and I just want to look up 2. I want to do this. I want to do this. So basically, I can do this. I can do staff ID, Pumjai, and staff ID, Atom Phone, right? And I put it in a list. Can I do that? Yeah, sure, I can do that. Okay, right? That makes sense. This is obvious, right? But here's the deal. What if I don't want to keep writing all this. I can do this. I can put Poomjai and Atom Font in the list first. Yeah. Now, what? Staff ID. Now, do you think this would work? It would not. Why? Because it's expecting one thing, and that one thing has to be a key. This is one thing, but this is list of key. So to say, I want to apply this, A stands for apply, to the element of the list. The shorthand is /. Okay, this is called mapping. Okay, but you might as well learn the shorthand. Nobody writes the word map. Okay. See that? It's saying I'm going to apply the lookup function. I'm going to apply, but I don't want to apply to just one guy. I want to apply the whole list of guys. So this is the notation. So if I did this, highlight and press F1, should go to the help page. Again, something with the keyboard, your keyboard doesn't allow me to do that. We'll figure out later. Okay, but most keyboard, my keyboard was Windows keyboard would allow you to do that. This is so powerful. Why? Because I can have this. My list. Define first. I just define this. And I just say something like staff ID apply to my list. Right? So I look up the ID for all of this. So this basically, if you want to do a procedural programming, what would you do? Anybody took C for summer school? Well, you have to say something like for I equal to 1 ... and then end of list. Okay, and then look up I from staff ID, something like that. Okay, it's gonna be involve some kind of for loop, so it's no good. By the way, some of you may get frustrated that, hey, wait, I get command here and I shift enter, but for some reason I shift enter, it does nothing. What happened is that the compiler tried to be intelligent. If you're writing something that doesn't look like a command, it's gonna assume that you're writing a text. So it turns this into a text. So now, even when you write something correct, I think you had that problem. It does nothing. Okay, because you already wrote something that didn't look like a command line. So Mathematica already assumed you were trying to write a plain text. So it turns into this thin character plain text. So now you can't do this. Means nothing. Nothing. Because it already knows it's a text. So what you have to do is just copy and somewhere else put it down. And now it's okay. So when you write command and you make too many grammatical error, it's gonna say, well, maybe this guy's trying to write a word or something, and after that you can't use it anymore. I think that's what you have. Okay, so that's it. So how would this be useful? It's gonna be so okay. Let me do this. Just a very quick example. Okay, and association. Okay, association. Oops, sorry. Again, that's not good. Go to a new line. Let's do this. Association. Okay. Let's do this. Let's say Poomjai Okay, let's do that. ภูมิใจ Okay. ภูมิใจ points to 1 and 2. Just something weird, right? Just something weird. And then atom font 2, 2 and 1. 2 and -3. Right. Okay. I'm going to name this association position. Okay. Okay, now watch this. List plot position. Okay. Doing this in Python will take you 10 more lines just to start matplotlib alone. Okay. So what it does. Oh, sorry. Basically, this association associate key with values. Okay. But this value appears as a 2D coordinate. Right? So when I go to list plot, it makes sense that I'm going to put Pumjai at 1, 2. I'm going to put atom font at 2 minus 4. Now, there's a 3D version of this, of course. What if I did this? What if I did this? 3D, and I add number, I don't know, 5, 0, okay? Position 3D, okay? So now it has 3 number. Would it make sense to do this? Yes, there's a function called list plot 3D and position 3D. Okay? Where's position 3D? Oh, sorry. I think I messed up some brackets somewhere anyway, so forgive me. It works, trust me, I use it all the time. I might have done something wrong. Okay, let's go back to the 2D example. Yeah. But trust me, it worked because I use it practically every day. Okay, so let's go back to this. Now, what it means is that if you look at the table from Excel, right? And I'll show you an extreme case. An extreme case is from my own application. I look up Jamwat for Thailand, right? Jamwat. Each Jamwat has a latitude and a longitude. So I have Grungthep Mahanakhon points to latitude, longitude. Okay. Actually, X direction is longitude. So Grungthep Mahanakhon points to longitude, latitude, and all that. And so in the end, I'm just going to show you this picture and then we're done for the day. Okay. This is a project I'm doing with meteorological data. But basically, I think it's this one. Yeah, I think it's this one. Okay. Forget the line, but I did exactly the same thing. Okay. So each name is associated with a position. So what it does is it just highlight the position with the name. So this is very nice way, instead of saying, okay, this is list of coordinate, this is a list of name. By using association, it understands, well, that's what we mean, right? Pumjai stands over here, Atapon stands over here, China stands over here, Hat Yai stands over here, Surat Thani stands over here, Bangkok stands over here. Forget the line, that's graph. By the way, the graph theoretic guy, I can talk to you about this later, but So that's it. So let's